Hi, in this video I wanted to show you all the various deformers and how they work. So I will show you this on two hair systems. One will be attached to the scalp, one to this plane. So let's start from the left. What I want to do is enable hair driving and then hold D and click with left mouse button and draw a bunch of strands. I will reduce the width of the profile. So I can do this both from the profile section in hair system or from the draft menu. There is also the same profile width parameter. So let's say I will draft only a few strands like that. And then I want to generate hair system on this. So I can disable drawing and I can use Ctrl+Shift+H add system strand generator, or I can use the hair system in here, subsystems, and click plus icon strand generation. And I can bump up density. For small objects, you will need big density. And to make it easier to see, I will disable the material with texture, and I will switch this to simple red material like this one. And we do not use UVs, so I can remove this deformer. And instead, I will add tilt, align tilt to surface, so it is looking slightly better. And then for the right hair system, I can click in the subsystems add and strand from grid surface, but we do not see any strands. And actually, instead of this, I prefer to use Ctrl+Shift+H cards from grid surface in here, because now it will show you that there are no edges marked as sharp. So I will fix that. I will use Shift+H to isolate active object, then tab into edit mode, alt right click on one border edge, Ctrl+E, mark sharp. So now this will work. I will tap into object mode and now use Ctrl+Shift+H, cut from grid surface, and now it is working correctly, except maybe I will reduce the width again for the profile, and I will bump up subdivision steps, and that is looking okay. I will use Alt-H to unhide the head, and I will use both of those meshes to show you various deformers and how to use them. The first deformer I will show is the align tilt to source surface. This is quite often added automatically by the add-on to your hair setup, but you can add this manually in the deformers. Click plus, tilt, align tilt to source surface, and it has few parameters. The mask, you can mask this input with various input masks. I made another video about them, but let's say I will use randomize. And now some strands will be aligned at 100%, some will be aligned at only 50%, some won't be aligned at all. The second input, twist fix, to show how it works, I will go to scalp mode, enable draft strands overlays, and I will comb the hair so it is going straight out of the surface. And depending on your hairstyle, for example, in this spot, you can see that we have some twisted strands. They do not look too good, but with twist fix enabled, those strands get straightened. And the way it works, it is using this fixed threshold angle parameter. For example, if I set this to 45 degrees, the way it works, it will compare 2 points. So for example, let's say this point normal is going this way, and the next point is kind of bended this way. The algorithm will compare those two angles, and if this angle is bigger than 45 degrees, it will consider those 2 points twisted. So it will take the second point and it will straighten it like so. So now this way the strands will get untwisted. And let's compare this to the setup on the right without tilt align and with tilt align. In this case, this works very good because the surface is going this way and the strand is following this surface mesh. So the algorithm has no trouble determining the align direction. I will now add the Braids Deformer, and in the bracket it says that the system has to be set as child or braids won't work. So I added the braids. They are forming because the current subsystem is having the parent tag set, And now I can maybe adjust the settings. So I will have to reduce the global size parameter first, because the braids are way too big. For small object, just type in smaller global size. Then I want to switch the profile. So we'll go to the profile and switch from flat to round. If you need UVs, use circle with UVs. In my case, I do not have any texture anyway, so I will use the round profile, and I will maybe reduce the width 10 times, like that. And now I do not have enough strands. I will jump to the strand generation, switch maybe this to random, and I will bump up density 10 times. The braids are kinda getting visible, but we do not have enough points on the curve, so I will increase steps subdivision, and now you can see the braids format. I will jump to the braids, and now I will show how the parameters. So the global size, the bigger the global size, the bigger the braids. Then we have the frequency, then there is the main radius. We have also the profile radius, so this will affect the substrands in the braid, and then there is the radius slide. So we have this tapered end on the braid. If I increase radius slide, the points are going closer to this end. If I reduce radius slide, the points are going away from this tapered end. And the taper itself comes from the radius of the parent strands. So maybe just to remind you, we are using the guide tag. This guide tag is assigned to the curve I created at the beginning. And the hair system is also attached to this curve. I can enable draft strands overlay to show better the parent guides. And for example, in this case, the radius of the parent strand is constant, so that's why we have no taper at all happening for this strand. I can tweak this and fix using Ctrl-Shift-H, taper curve, use this taper curve like that, and now you see all the braids are tapered. So I can now maybe increase radius slide like that, maybe increase the frequency slightly, and we get this kind of look. Finally, influence range. The smaller the value, the faster the braid will form. If I increase this parameter, then the braids will form later. Okay, so for the game character, you would probably want to switch the profile to the circle with UVs, and also we have too many of strands, so I would have to reduce the density of strands. But now one problem will be obvious. For example, in this spot, we have a sub-braid made only from few strands, and this part has way more strands, so it is not uniform. And this is like big disadvantage of this method, and later I will show you a better method with more uniform distribution of the strands. So now I will explain the color set deformer. I can increase and maybe change the color, but nothing changes. It is because this color set is outputting special attribute, and I have to use this attribute in the shader. So I will switch to the shader editor, and rather than using this red color, I will use Ctrl-Shift-H, import the default material, and now I will edit this default hair material in the shader. We have a bunch of input attributes visible on the top left, and one of those attributes is the system color. I can output this to the material output, and you see this green color that was set in the deformer color set. So you can use this to colorize hair strands, and in this case there is only one system, one subsystem, but if I added more, it can help you visualize which strand belongs to which subsystem. So I will add another maybe subsystem, bump up density, maybe reduce length, and I can also colorize this with color set and make this red. So I will maybe name this red system, and the first subsystem name green or yellow. And now the interpolation on the second system, in this case, even though we have set the parent tag to guide, it is not interpolating correctly. It is because in the first system, strand generation, I enabled remove parent strands. So now any subsystem after first one does not see those guide tag strands. So I will disable removement of parent strands, and automatically second system is now following the guide tag strands. Also, when I disabled removement of parent strands, you can now see those parent guide tag strands. They are black, and they are not colored because the first color set is only colorizing the strands generated in the first system. Then the color set in the second subsystem is only colorizing the strands from the second subsystem, and there is nothing that is colorizing the guide tag strands. There is a way around this. For example, let's add the strand filter, and if I add color set and maybe change the color set to blue, everything gets colorized to blue. But I will now copy this guide tag, and in the filter paste this into the filter tag, and now you see we are now colorizing only those strands with guide tag. I will now add the next deformer, Clump Deformer. It requires current system to be set as child, or this won't work. So this worked okay because in the parent tag I entered this guide tag, and let's visualize the parent strands in the viewport overlays. And this has only two parameters. I can reduce the clump effect in the first slider, and to get more interesting look I would add maybe randomize, increase the randomization, and then plug in offset gain, increase the gain, and maybe play with the offset. And this looks way more natural and interesting compared to just the default behavior without any input mask. The influence range, if I reduce this, then the effect will happen faster. If I increase this parameter, then the effect will happen only at the endings of the strands. So now let's jump to the curls deformer, and I will reduce the size, global size, reduce maybe frequency. We do not have enough point, so in the strand generation I will bump up subdivision steps and then reduce frequency even more, maybe reduce amplitude somewhat, and then I want to switch influence range to the profile curve, and I will flatten the first half and maybe bump up the second half, and we get effect like this. I will skip the flatten for now. Gravity will move the curls to the bottom. Phase will change the phase like so. I will skip also the width and influence width. Project to normal. Now the curls are only moving out and in to the surface. They are not moving to the sides. And there is also project from normal. So this has the opposite effect. Now the curls are only moving to the side and not at all moving out of the surface. And the last two parameters also, it will be easier to see on the left. So if you want to get more maybe varied look, you could always add maybe randomize to frequency, so it is not so boring and not so uniform. Okay, so now I will show you the missing parameters. It will be easier to the system. So in here I will add curls again reduce the global size, go to the strands and bump up the subdivisions, and okay, so I will switch the profile to the round profile just so that we will see how this works. And okay, in the curls I wanted to show you how it would look if we use parent space. So now the curls are forming around the guide curves. I will show them in the graph strands overlay, and we do not have enough points, so I will reduce spacing and maybe increase slightly density. And okay, so there is the width parameter. The width parameter itself, it is not changing width of the individual strands. It is changing the width of the whole clump of strands that form the curl around the parent. The flatten parameter, now it will be easier to see how it works. You see we have this very hollow looking curl, and if I unflatten, then the curl is getting narrower, but also it has more volume more volume inside. And also, let's say I want to align tilt to the parent strands. So I will quickly switch the profile to flat type, reduce width. And okay, let's see how this would look if I enable align tilt. And as you can see, it may be somewhat better, but it is not perfect. Some strands are not aligned at all to the parents, and that's why, depending on your needs, you may go to the disable the curls generation from the deformer, and instead you may want to use the curls profile in the profile section. So this will give you the perfectly aligned curls toward the center of the strand. So yeah, that is all about the curls deformer. Now I will add the strand generators, duplicate strands, and it is one big mess. So I will disable the duplication, go to strand generator and increase the spacing. Okay, so with that it will be easier to see what is going on, and I will reduce the radius. And you can already see that all it does, it is duplicating the strands. It is very simple. You can define the amount of duplicates. You can mask this with, for example, a vertex group in this input, so that less duplicates could be generated maybe in the bottom. There is the radius parameter. There is the distribution shape. So if I set this to -1, we have this kind of effect. If I set this to +1, you get this kind of effect. And on the 0, you have this kind of effect. And there is the tip roundness. So by default, all the strands are generated in this area. If I increase the roundness, it will be spawned in this like sphere area. And finally, even thickness, it will use original strand tangent space to distribute the duplicates. And this deformer is looking quite simple, but you can combine this and get very interesting results. For example, if I combine this with Clump, and maybe I will invert the influence range, then the first thing I wanted to show is that those strands are clumping not toward the parent guide strand, they are clumping toward the original strand they were created from. So for example, they were created from those 2 points, those 2 strands, and now when I enable clumping, it is using this original strand as parent for those duplicates. So the original guide parent strands are completely ignored after you add duplicate strands. And let's switch maybe influence range to profile curve. I will bump up clumping everywhere to 1, except on the center, and we get this kind of effect. Maybe I will add simple scale before duplication, so those strands will be longer, like that. And also I wanted to show you that it is useful to combine the tilt align to parent, and I will switch influence range to constant value, so everything is aligned 100% over the whole length of strand. Okay, so we have the aligning to parent, but it is not looking great. It is because in the root, all of those duplicates are going to this one point, and align tilt kind of has trouble working. The same is true on the tip. And the solution is to give some breathing space between those duplicated roots and the original root. And the easiest fix is to go to Clump and reduce the clump from 1 to 0.999, and now the aligning to tilt works correctly, because we just gave some little space in the root and in the tip. So for example, if I now go to the duplicate strands, I can increase radius and we get this kind of effect. I can go to distribution shape, set this to -1, so most of the duplicates will be around the radius. Then I can maybe add radius set to taper those strands, switch influence range to curve and make it like so. So you can see you can get kind of interesting results if you combine this simple duplicator with all the other deformers. And let's say, for example, I don't like the radius of those shorter strands. So what I can do, I can link the radius with mask, length mask, so that we get smaller radius for shorter strands like this. But I do not want to get 0 radius, so I will bump up the minimum radius to 0.4. So now we get smaller radius for shorter strands like that. And now I could bump up again the density, maybe not as much. And yeah, you could get some interesting results if you play with all those deformers and combine everything. So now I will add next deformer in the generator. There is Braids Generator, and as usual, first reduce the global scale and tweak this to your object size. We have too many strands, so I will increase spacing between strands like so. And now we have a few strands, and if I enable strand generator, each of this strand is duplicated 3 times, and then the braid is created. The idea is to use this with the circle profile with UVs. I will reduce the size, and we have something that looks very similar to what it would look like if we just used the braid profile. So why do I just cut and make this generator, braid generator? Well, the idea is we can now add a bunch of deformers on top of this braid generated this way. And if I just used braid profile, we would not have this option. So for example, the way I thought about this is to add a bunch of duplicated strands for this braid, then reduce the radius and maybe make it something like that. And now each of those strands is made from 10 duplicates. So this will give us a uniformly looking braid, because previously, if you remember, when I showed the Braids Deformer, it would just grab a bunch of child strands. So sometimes it would grab 2 strands, sometimes it would grab 10, and this would give us a very non-uniform looking braid. But here it is no issue, because each of those 3 strands is duplicated 10 times, so we have a perfectly looking braid. And okay, so I will maybe reduce the width slightly, and we have some parameters. So there is a global scale, we can adjust the frequency, the main radius, we can also increase or decrease resolution in here and slide the points. And one issue currently with the braid is that it is not tapered, and this is the same as in the normal braid. If the parent strand is not tapered, then the braid is also not tapered. So this is the parent strand. So to fix this, I will go and add a radius set deformer above the braid generator. Also, maybe I will scale this somewhat. And now if I enable braid generator, you see we have perfect taper. I can maybe slide those points slightly to the front, enable duplication, and then there is one more issue. After enabling duplication, those duplicated strands are spawned in radius around the tip. Here it is maybe actually good for us, because we do not want to overlap all those duplicates on top of the original strand, but here it is not good. And fix is easy, just add Clump Deformer, and now everything is, every duplicate is clumped and going toward the original strand. This is maybe actually a bit strong, so I will increase influence range like that. And let's see how this would look with texture. So I will use Ctrl-Shift-H and import default hair material. And we have result like this, so it is quite uniform, and you can play always with the settings. So we can maybe increase the frequency, we could generate more or less strands. You could play with using different UV region, maybe more semi-transparent, so it is not so dense and shell-like looking. You could add maybe, for example, tilt and add tilt deformer. Then we could bump up the tilt like that, adjust some parameters, and thanks to this now it is not going straight, but we have some intersections overlapping happening. I could maybe then on top of that randomize the tilt like so. You could add also other deformers like maybe radius set and randomize radius. You could add noise, so you have full flexibility with this setup. Now I will show you how to use the instance on strand. It is very simple. You just copy the object name. In my case, I have this torus. I will paste this into instance on strand. And now this torus will be instanced on the curve. I can adjust the scale, move this along the length of the strand like so. And in my case, I have a bunch of other deformers that will create this ponytail, and also I have child system, and with this setup I can then just duplicate everything as one object like that, and I do not have to worry about selecting this torus as separate entity. So I can now comp this and get some interesting results. If you want, you can also instance collection rather than object. So in that case, just select use collection and pick collection you want to instance. Okay, let's add another deformer. So this is in the section move in out of the surface. First one is embed roots, and if I set this offset to some small negative value, it will move the roots into the source surface. It is still too big, so I will reduce this more. And this is without, and this is with. And sometimes it can mess up your alignment of the strands. So that's why it is best to move this above the align tilt deformer, so that align tilt will handle the orientation of the hair cards. There is also the influence range offset. If it is set to high value, only the very roots will be affected. If you reduce the influence range, then the whole strand length can be affected by this offset deformer. I will now add the remaining two deformers from the move in out of the surface section. The second one is push out. It will just move the strands away from the surface. You can switch this surface to the different object in here, and then just click use custom target. You have option to smooth out those strands, and the influence range, the bigger it is, the more the effect will be moved only to the endings of the strands. So there is also one more deformer in the section snap. It will just move the strands closer to the source surface like that from both sides. And there is also option to use custom target, and influence range works the same way. And both of those deformers are very useful. For example, you can combine them with the noise. So let's first add noise deformer with smaller value of the amplitude. And then I want to fix some issues. So for example, noise moved too much the strands into the head, and some strands maybe are moved slightly too much outside of the head surface. So I will now add the snap and increase the snapping factor like that. So now the noise is kind of squashed from both directions. And finally I can fix also this with the push out deformer like that. And also this technique can be used to the to get effect of layered hairstyle. So I will just quickly copy the active subsystem, create a new one, paste the same settings, and now I will unlink the second copy so that When I adjust the second system, it won't affect the first one below. So now I can increase the push out, and you see we get kinda this effect of layered hair strands. Now they are sharing the same noise, but I can just change the seed in the noise, and we get different looking top and bottom layer. So this is very easy and best way, in my opinion, to create these layered hairstyles. Now I will add the Lengthen Deformer. It will extend the strands, taking into account the curvature of the strand. So it won't just lengthen them in the straight direction, it will kinda bend them like so. Now let's add the Mirror Deformer, and it is quite simple. It will mirror right side to the left and left to the right. So at the same time it will also double the strand count. You can use bisect, so this way first it will remove one side and only then mirror the other side. If you select flip, then this will flip the effect. And finally there is the bisect distance, so only if the bisect is enabled it will remove some strands in the center. This is similar how it works in the mirror modifier for the mesh object. And finally you can depict different mirror origin object in here. And it is important to know that mirror only is affecting the strands above. So for example, if the noise is above the mirror, then this noise will be mirrored. But if I move the noise below mirror, then it will create the unique noise for now left and right side, because it is now after the mirror, so mirror is not affecting this noise anymore. Now let's add the noise deformer, and as usual we have the global scale. So for small object, type in global, smaller global size. We have the uniform section and per strand section. So I will remove for now the per strand noise, and now we just see the uniform noise, and this will give the uniform flow to all the hair strands. You have control over amplitude. You can increase or decrease the frequency of the noise like so, and we can also change the seed. And quite often the noise will move the strands into the surface of the head, so then just add the Pus Out Deformer so that it will fix that issue. Let's now jump to the per strand noise section. So I will set the uniform amplitude to 0, increase per strand amplitude, and we get this kind of result. So now each strand has its own noise distribution. So this will be good for more messy hairstyles. So again, we have the same controls, the frequency, the seed, and finally there is the influence range. If I increase this parameter, then the noise will be moved mostly to the endings of the strands, like so. And also there is the tangent constraint. In some cases, if the noise is too much, gives too much deformation to the strand, you can enable this tangent constraint to kinda smooth out the deformation. Let's add now the radius set deformer. It will taper the strands and you can adjust the radius like so. And I would suggest to keep the radius close to 1. And if you want to change the width of profile, then go to the profile section and change the profile width in here. And this input is mostly exposed, for example, to use with masking, with vertex group, for example, or with randomize. I could now randomize the width like so. Then there is the influence range input, so this will affect the radius over the length of the strand, like so. You could always swap this to the, for example, profile curve, and then manually control the radius like so. So we have tapered both root and tip. Finally, we have the mask. And if I set mask to 0, we see no effect of the radius set deformer. I can set this to 50%. Now the strands are tapered, but not 100%, but only 50%. Finally, we have the build-up, and it is not affecting the strands, but for example, let's add another radius set deformer. We see the second radius set is tapering the tips, but we can still see the effect of the first radius set deformer, and this is thanks to the build-up option. If I disable build-up option, now we won't see any effect of the previous radius set deformer. I will show you now the roll deformer. It is basically the same as in the default Blender roll, except few changes. So we have the factor, this will reduce the effect. We have the roll length, it will increase the distance of the rolling. We have the roll radius, this will reduce the size of the circle at the end. There is the roll depth, so let's imagine each circle at the end has some normal, and using roll depth will move along this normal like that. There is the roll taper. This will make the circle smaller at the ending of the strands like that. There is the retain overall shape. This will force the strands to go closer to their original position from before they were rolled. There is new option roll along surface. This will take the source surface normal and force the roll direction to use this normal. If you want, you can use different object normals by plugging in a different object in here and then click use external surface. For example, in this case on the left, we have hair system that is attached to this scalp mesh, and if we had longer strands, this scalp mesh would be too short for sampling normals, so you could create maybe mesh like that, and you then use this for sampling normal direction in the roll deformer. So this would create a better result. We have also option to change the roll direction like that. You can randomize this direction like so, and finally there is the seed to adjust the seed for random direction, and finally we have the use parent IDs. So let's say this clump of strands had one parent, and so rather than assigning random direction for each of them, they would get one random direction based on the parent ID they belong to. I will add now the scale deformer. We have only one slider available. It will just scale the strands in uniform fashion like this. You could mask the input maybe with vertex group or with randomized input mask. And the advantage of this deformer, it is very cheap to compute. Let's add the same deformer for the hair system on the right. If I scale the strands, you get something like this. It is probably not what you are looking for. So for this kind of hairstyle, I would suggest to use Lengthen Deformer. Now I will add the Simplify Strands Deformer. It is very simple. The way it works, it will assign the minimum point count to the shortest strands, and it will assign the maximum point count to the longest strands. You can use this to optimize the poly count in your hair. Let's see how the slide deformer points work, and it will be easier to see if I switch the influence range from simple to profile curve. I will set the profile to look like this, and the idea is in the places where the value is low, so in the root and in the tip, we will have low spacing of the points, and in the center we have high value, so this will give us high spacing between points. So this can be used to move the points in the places where you need them. Okay, so now let's see how the smooth strands works. It is quite simple. You can just increase the iterations to smooth out the strands more. The amount, if I set this to negative value, it will invert the smoothing effect, so everything will become more wavy rather than straight. The influence range, if I increase this, then the smoothing will be moved mostly toward the endings of the strands. And the weight, it is just additional option to control the smoothing. So rather than having the integer iterations, you can adjust this with the float value. Now let's see the tag section. In here we have the assign tag option. Let's assign a t tag to all the strands, but I would rather use the mask input value with the randomized input mask to only pick some of the strands. So the way it works, if the random value is given to the strand above 0.5, it will assign a t tag to it. And to see the effect, let's add the strands filter. and I will filter by this T tag. So now if I add maybe radius set to taper the strands, you see all the strands that receive T tag now are affected by the filter system. I could maybe rename this to taper, and I can go back to the assign tag, change the seed, and we get this kind of effect. And also in the tag section there is option to delete strands, so I will plug in the same T tag, and now all the strands that received the T tag are removed. Let's see how the align tilt to parent works. So obviously this requires parent strand to exist. In my case I have those yellow parent strands. I added child system, and let's add tilt align to parent deformer, and we see the tilt is aligned but only on the top portion of the strands. So I will switch influence range to constant, so this way whole child strand is aligned. If you have some ugly twisting, then just enable twist fix, and this is the result we get. Now let's see how the align tilt to mesh border works. So we have this hair system. It is spawned from this mesh surface, and we will use the border of this mesh to align tilt to. So in the hair system, I will go to the add deformer. In the tilt section, there is align tilt to mesh border, and it is working correctly. We can see back faces in blue. And let's say I will move the guide curve to the left, and you will see that some strands change color and orientation to the right side. If you do not want this behavior, you can go to the align tilt deformer and use the force alignment. This will make it so that not only tilt but also normal is aligned to the closest border edge, like this. There is also option to limit the distance of affected strands. Here it is a bit narrow, so it may be hard to see, but if I set this above 0 value, only strands below this distance will be aligned to the border. And finally, influence range. This will modulate the effect based on the position on the strand. If you want to align whole strand, then switch this from simple to constant. This way whole strand will be aligned 100%. Now let's see how the align tilt to target works. So from the deformer list I will add tilt align to target, and it has exactly the same parameters as normal align to the source surface, except you can pick different object. So in here I will click on the picker icon, left click on the mesh, on the plane I created, and when I rotate the plane you see the haircuts are aligned to this mesh. If you see some ugly twisting happening, just use the twist fix button. This is exactly the same as in the normal align to the source surface deformer. So now let's see how the add tilt works. Basically you just type in an angle in the first input, and the strand will slowly rotate in that direction. You can limit the effect by increasing influence range to only the endings of the strands, like so. And you can see that some strands are rotated 44 degrees counterclockwise, some are rotated 44 degrees clockwise. It is driven by this flip probability. If I set this to 0, everything is rotated counterclockwise. If I rotate this to 1, set this to 1, then everything is rotated clockwise. And there is the flip seed that will assign different rotation direction per each strand. And finally, there is flip uses parent ID. Let's say we had the parent tag assigned to the system, and maybe 4 of those strands would be assigned to one parent strand. Then they would receive the same rotation if you enabled flip uses parent ID. Let's add now the track to mesh deformer, and the first input you have to pick the mesh. I created this plane on the top, so I will use this as track target. And now the tips of the strands are following the mesh, except if I move the plane, you see that the points are sliding on the surface. So I will go back to the track to mesh, press bind track mesh. Now if I move the points, you see that the tips are glued to the surface. I will make another video just about this technique, but for now I will explain just quickly how some of the parameters work. So I can change this linear to blend factor. When I set this to 0, we have linear interpolation. When I increase this parameter, we have this bending behavior. There is the influence range slider that works this way. There is the bend strength parameter, and we have also the mean distance bend. When I set this to 0, now the strands that are closest to the tracked mesh will be straight. And if I set both parameters to 0, now all of those strands, even that are further away, will be bent. And just to give you idea, if you, for example, split the tracked mesh with Y key and move this like so, you basically get the hairstyle with split. Now I will show you the track to curve deformer, but first we will add the track curve. So I will go to the use Shift A and add curve using Shift A menu and Bezier curve. I will go to the top view using free key, then tap into edit mode, rotate everything 90 degrees and scale to the X axis to the 0 value. And I can maybe scale everything slightly. And let's say from the side view, this is looking more or less okay. We will tweak this later. So I will now add the track to curve deformer, and in here I will pick the curve I just created, and the strands will now follow this curve. And the idea is that the strands will follow and snap to the closest point based on the root position of the strands. So for example, a bunch of those strands try to search for closest point on the track curve, and the closest point they found is in here. So I want to even out the spacing, and for that I will move the tracked curve until the spacing is more even, so something like here it is better looking. I can maybe also adjust the top part, and basically I am trying to follow the shape of the root position of the strands, and I will try to mimic that in the curve. So this looks good enough. I will go to the hair strands and press bind to track curve. And okay, some of the strands moved slightly. The issue is that the old Bezier curves do not support curve attributes, so the only way to use the bind option is to convert the old curve to new curve. So that's why the look on the curve is slightly different. I can maybe select all the points in the edit mode, use Ctrl-Shift-H, and then I can use the resample to add a bit more points. So I will maybe resample this to 6 points, and let's say this is looking good enough. So the curve is binded to the hair system, so I can move this like so, and the points won't slide around. So let's say this is looking good enough. I can maybe add the option. I will add track tilt align and align to border mesh so that we get better aligned hair strands. So now I will explain some options in the track to curve. There is the linear to bend factor. When I set this to 0, the strands will go in the straight line toward the tracked curve. If I increase this bend factor, then the strands will curve more. There is the influence range. If I adjust the influence range, we get an effect like this. We have the bend strength, so if I bump this up, the strands will be more curved like that. And there is the mean distance bend. If I reduce this to 0, then the strands that are closest to the tracked surface, so for example in here, they will be linearly interpolated without any bending. If I reduce the max distance, then also the farthest away strands also will be linearly interpolated. So maybe I will get something around this, looks okay. And lastly, there is the separate target per island. Currently, the hair strands are spawned from this surface. Maybe If I disable modifiers, this is the surface the hair strands are spawned from. This is just one island. But let's say I would select a bunch of those vertices and maybe split this island in two. To make it easier to see, I will move this slightly outside, and I did not split this correctly, it seems. So I will repeat. I think I have soft selection. Let's try again. Okay, so it is dark, but now you see we have two islands. Let's enable the modifiers. And now when I have enabled the separate target per island, if I move the curve, you will see only one mesh island, and the strands belonging the front island are now tracking the curve. The strands that are on the island from the back, they are ignoring the tracked mesh. And it is because if I show you maybe the origin of the object, of the curve, the origin of the curve is closest to the front island. So that's why those strands are only tracking the curve now. And if I move, for example, in object mode, we can move the tracked curve. Now the origin is closer to the second island, and so now second island strands are interpolated to the curve. If I move this in edit mode, I obviously do not move the origin then on the curve, so it does not matter. I can bend this as much as I want. And so if I disable this separate per island option, now all the strands from both front and back islands, both of them will track to the curve correctly. Now let's see how the trim and deformer works. It is very simple. You can trim the roots like that. You can trim the tips, and usually you would want to combine the tip trimming with, for example, randomize input mask to get effect like that. And there is one parameter in here, keep point count. So basically with this disabled, the shorter strands will get less points. And if I enable this parameter, then all the strands independent on the length will receive the same point count. Now let's look at the twist deformer. As you can see in the bracket, it requires hair system to be set as child, which is the case in here. I will increase the strand resolution by going to the strand generator and bumping up subdivision steps like so. Now maybe I will reduce the width of the profile. And now let's see the settings for the twist. We have the global size parameter, we have the amplitude, we have the frequency control. I can change the influence range. If I reduce this parameter, the effect will start faster at the roots. I can increase the gravity to move the effect more toward the tips. There is the phase control also, like so. So currently the distribution is not even, because if I showed you the parent strands, then you see those parent strands are not even. I could go to sculpt mode, and using add brush, I could manually add more of those strands like so. But this would be kind of time consuming and not very procedural. So there is a better way to do this. For now, I will just maybe increase the strands puffness, so they are going more straight out of the surface like so. And now let's go to the hair system. I will disable twist for now. We do not need align tilt. I will remove this, and I want to increase spacing between those strands. So I will bump up spacing twice. And now the idea is to use the generator duplicate strands. If I reduce the radius of duplicated strands, now we will get something like that. If I enable twist, we have now perfectly uniformly looking twisted strands, because each of those is made exactly from 10 duplicates. So I could maybe increase the amplitude like that. And let's say how it would look if I tapered the twist. The way to taper the twist is to add the Clump Deformer. and maybe I will increase the influence range, and we have this effect of tapering thanks to the Clump Deformer. On top of that, I can maybe make the strands themselves sharper by adding the radius set deformer. So now the endings are sharper. Let's see how this would look if I added maybe length to the shorter strands. So I could go to the strand generator just above the duplicate strands, and in here I would add the scale deformer. Now if I increase scale, this will lengthen all the strands, and I want to add more length to the shorter strands, so I will use the length mask. And now we have exactly the opposite effect. The longest strands got even longer, so I will invert the effect of length mask. I want full strength for the shorter strands, and I want maybe around like 50% for the longest strands. So now we get something like this. If I maybe increase the amplitude even more, we get something like that. Let's see how this would look if I scaled the strands, make them shorter. We get something like this. So I think you get the idea. With some tweaking, you could probably get some interesting results with this hairstyle. Now I will show you the last deformer, the UV region distribute. It is doing nothing currently because we have no visible texture. So I will use Ctrl-Shift-H, import default hair material. This will import the shader, the texture, and also it will assign default UVs to the hair strands. So if I disable the deformer, we see no texture because this UV region distribute is responsible for assigning different fragments of UVs and different fragments of texture to the hair strands. And however, this is not holding the UVs. UVs are stored in the profile, so even if I remove the UV region distribute, then add this back, you will see it is not affecting the UVs at all. It is just responsible for distributing UVs on the strands. So I will jump to the UV image editor. I will add new texture, so it will be easier to see with this texture what is going on. You can middle mouse button scroll on the header and then click the hair UV. This is how the default UV look that were imported with the import button. I can left click and drag by the corners to resize the box. I can just left click and drag to add new UV box like so. I will just add more UV boxes and then just press enter to save. And now I want to assign this texture to the hair shader. So I will jump to the shading tab. In here I will open the default hair material. And let's find the texture node. This is currently using the texture in here of the hair strands, and I want to switch this texture to the new one I just created. So I will pick the untitled texture like so, and something changed in the viewport, but it is hard to see. It is because we are using this hair shader. So I will just link the texture node directly to the material output, and we can now clearly see the UVs are distributed on the strands. Let's jump to the UV region distribute node, and it has a few parameters. So currently we are using all UV regions. There is the seed value, so we can change this to assign different parts of texture to different strands and randomize this. You can click on the set UV regions to then manually pick with left mouse button which fragment of the texture you want to assign to the current hair system. If you shift click, then it will allow you to pick multiple regions like so, then just press enter to save the selection. Now I will add one more time UV region distribute. I will pick the fragments on the right, and I will save this pressing enter. Okay, and we have now this mask input. I can maybe use, for example, the length mask in here. And now you see the longest strands are receiving the blue fragments of texture. The shorter strands are receiving the yellowish parts of texture. And the yellowish parts are received from the bottom deformer from the previous region distribute. If I disable this previous UV region distribute, the hair strands, the shorter hair strands would not receive the UVs at all. Okay, so if you add, for example, one more hair system, you will see that it is not receiving any UVs by default. You have to repeat those steps again. So you would just go to the deformers and add UV region distribute again. However, if you want to assign the UVs to all hair subsystems, I could maybe remove all the UV region distribute just to show you. After the last hair subsystem, just add strands filter, and then in the last strands filter, add the UV region distribute, and this will assign the UVs to all the previously generated strands, like so. So I think that covers everything about the workflow with the UV region distribute node. So in this video I covered all the available deformers. In the previous one I showed you how to use the input masks, and later I will also make video about the strand generator and strands from grid surface, but this video is already too long, so I will end this in here. Hope you like this content, and see ya.